Okay, back to solving inequalities. Again, I notice I have an x squared. If I have an x squared, I better have 0 on one side. I already do. Now I need to factor. And what makes this one challenging is this first number right here is not the number 1. So you got to go back and remember how we factor things like that. When this first thing is not the number 1, we multiply the ends. 12 times negative 6 is negative 72. And then I need to be able to factor negative 72 to come up with a 1 in the middle. And I think the way to do that is 9 minus 8. 9 minus 8 is definitely 1. And 9 times negative 8 is negative 72. Okay, so we rewrite this as 12x squared plus 9x minus 8x minus 6 bigger than 0. 4 pieces, we group them. First group has 3x in common, and left over is 4x plus 3. Second group, because of that minus, has a negative 2 in common. Factor out the negative 2, becomes 4x plus 3. Remember that sign changes when you factor out the negative. Greater than 0. 4x plus 3's match exactly, so I write those down. 4x plus 3. Left over, 3x minus 2, bigger than 0. Alright, now truthfully, that's the hardest part of this problem right there. The hardest part is factoring it out. Now that we've factored, we solve it. 4x plus 3 equals 0. Solve it like it's an equation, I should have said. 3x minus 2 equals 0. This one is x equals negative 3/4, and this one is x equals 2/3. Alright, that tends to scare people a bit on problems like this when they get fractions for answers here. The good news is fractions really are not going to be a problem. And I'll show you why. Negative 3/4, 2/3. No equal to, so we put circles. Here's why these fractions are not a problem. You get to pick your favorite number in the whole wide world bigger than 2/3. Pick a nice number like x equals 1. That's exactly what I would use. X equals 1. Again, I'm going to take 1 and plug it into the factored form because it's a lot easier. If I plug 1 in, I get 4 plus 3, that's 7. Times, if I plug 1 in there, I get 3 minus 2, that's 1. 7 times 1 is 7. 7 is bigger than 0. So that way it works. Favorite number in the middle. Well, since this one's negative and this one's positive, 0 is right in the middle. So I use 0. 3 times negative 2, that's a negative 6. Negative 6 is not bigger than 0. So since 0 didn't work, nothing works. And again, the fact that this is a fraction is not a big deal because I'm going to pick my favorite number down here. I'm going to use negative 1. When I plug in negative 1, I get negative 4 plus 3. That's negative 1. And then I get negative 3 minus 2. That's negative 5. But negative 1 times negative 5 is positive 5. And positive 5 is bigger than 0. So that one worked. Once again, 2 separate chunks shaded. They're not connected. When they're not connected, we need 2 separate answers. X less than minus 3/4 and x bigger than 2/3. Or in interval notation, negative infinity to negative 3/4 union 2/3 to infinity. And it's all round brackets because we didn't have any equal to's anywhere in this problem. Okay, 2 more to go. The fact that we have an x cubed right here doesn't change much. We still have to have 0 on one side. We do. We have to factor. This time to factor, we can take out a GCF of an x. X times x squared minus 4 less than or equal to 0. And then x squared minus 4 factors. X x minus 2 and x plus 2 less than or equal to 0. Now, I would hope for this one you could draw your number line right away. I would hope you would see that this one's going to give you 0. This one you're going to have to add 2 to both sides, so you're going to get 2. And this one you're going to have to subtract 2 on both sides, so you're going to get negative 2. We have the equal, so all of them get dots. Here's where having the x cubed changes things. Instead of having 3 regions like we've had in all the other problems, now we have 1, 2, 3, 4 regions. We just got to plug in more numbers. Really not a problem. I like to start at the right. So I would pick 3. When I plug in 3, I'm going to have 3 times 1 times 5. That's 15. 15 smaller than 0? Not today. X equals 1. When I plug in 1, I'm going to have 1 times negative 1 times 3. That's negative 3. Negative 3 is smaller than 0, so the region where 1 is works. Next, I guess I would try negative 1. That's going to give me negative 1 times negative 3 times 1. That's 3. 3 is not less than 0. Cross that off. And finally, x equals negative 3. Negative 3. Negative 5. And negative 1. That's negative 15. Negative 15 is less than 0. So that's good. Again, notice we have 2 distinct separate chunks shaded. When that happens, we need to write 2 distinct answers. This one is x less than or equal to negative 2. And this one is x is in between 0 and 2. In interval notation, negative infinity to negative 2, union 0 to 2. Okay, last one. Let's see, this one. First thing I notice is I have x squared, but I do not have 0 on one side. Got to fix that. 3x squared, subtract the 3x, that's going to give me a negative 8x. Add the 6, that's going to give me negative 3, greater than or equal to 0. Similar to question number 3 in the sense that we have to factor, and that's not the number 0, that's not the number 1. Multiply my ends. 3 times negative 3 is negative 9. So I guess I'm going to go negative 9 plus 1 to get that negative 8 in the middle. And negative 9 times 1 does give me negative 9. So 3x squared minus 9x plus 1x. I didn't really need to write the 1, but I did out of habit. Minus 3 greater than or equal to 0. First group, 3x comes out. X minus 3 left over. Second group, nothing comes out, but that's okay because the x minus 3 matches the x minus 3. So we factor out the x minus 3. Left over 3x plus, remember there's a 1 right there that we don't write, greater than or equal to 0. Drawing my number line. This one I would add 3 to both sides, so that's going to be a 3. This one, you have to subtract 1 and then divide by 3, so that's going to be a negative 1/3. If you need to write that down, write it down. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. I'm thinking at this point, probably most of you don't need to write it down, but if you do feel comfortable writing it down, if you feel like you need that, then write it down. All right, this time we have equal to. So we have nice big dots. Favorite number bigger than 3 is 4. When I plug in 4, I get 1. kind of move this here so we can see everything. There we go. 1 times 12 plus 1 is 13. That's 13. 13 is bigger than 0. We like that region. X equals 0 is in the middle. That's going to be negative 3 times 1. That's no good because it's not bigger than 0. And finally down here, again, the fact that this is a fraction, don't let that bother you. Don't pick a fraction, pick a nice number. A nice number down here is negative 1. When I plug in negative 1, I get negative 4 times negative 2. Negative 4 times negative 2 is 8. 8 is indeed bigger than 0. So, final answer. X less than negative 1/3, or X is bigger than 3. And equal to on both of those, because we do have the dots. Interval notation, negative 1, oops, wrote that backwards, sorry. It should be negative infinity to negative 1/3. Union 3 to infinity. Okay, so that's it for quadratic inequalities.